Good morning. Welcome to the Windows Application Lifecycle session. I'm Chris Cortez, a program manager on the development platform team. This session is going to cover the lifecycle of your application after it's installed on a device and a user begins interacting with it. So the Windows platform is targeting 1 billion devices and is currently 270 million plus strong. Now, Windows is running on the most powerful desktops imaginable, to Xboxes, to the tiniest tablets and mobile devices. What do you as a developer want to get out of this ecosystem? Well, you want a consistently great user experience for your apps. You want fast, fluid, responsive applications. And the application lifecycle is a consistent set of tools across this ecosystem that you have to make your experience great. Now, some tools are given to you by default, right as part of the app templates in Visual Studio. And these are the basics of the application lifecycle. We'll be covering them briefly first. Then we have some exciting new features to show you around activating your application in the background and enabling your application to move seamlessly back and forth from foreground to background for better multitasking scenarios. Finally, we'll introduce an easier way for you to dynamically manage the most important resource your application has, memory. After that, we'll have time for any questions that you may have. So let's start with the basics of the app lifecycle. Now, your application can be in one of three states. It can be in not running, running, or suspended. Now, if the user has not yet launched your application, it's in the not running state. When the user launches your application, the on-launch callback is then initiated, and your application moves to the running state. So for other types of activations, such as directly through a file opening contract, for example, a form of on-activated is instead going to be invoked for you to use. Now, when a user minimizes an application on desktop or moves away from it to another app on a mobile device, that application then moves into the suspended state. Now, the suspending event is fired to take any actions necessary before your application moves into the suspended state. When the application is then maximized on desktop or returned to on mobile, then that application moves back into the running state, with the resuming event firing during that transition. And finally, when a user closes an application, it moves into the not running state. And the move between suspended and not running is the only transition to not have an event actually associated with it. So let's look at how a user's daily app usage pattern actually affects your resource usage of your application. So let's take an example of a social networking application. When the user launches your application, you've got access to two resources that are imperative to good user experience: memory and CPU usage. So in the running state, the application uses these resources to load an activity feed that the user can browse in this example. And when the user minimizes the application and moves to another activity, in this example, the social networking app is then suspended. So after that suspending callback, the app is given no CPU cycles to run, and memory is preserved in a frozen state. So an app doesn't actually have to do any work to be preserved in memory during suspend. That will be given as a default action that will happen. When the user moves back to look at their feed, then the resuming event is fired, and then your app moves back into the running state again. So an application will commonly move back and forth from the running to the suspended state throughout the day, as the user moves back and forth from it to other activities, other applications, until the user finally chooses to close it. So on desktop, closing is accomplished using that X close button. And then on mobile, this is done by going into the back stack and either using the X button or swiping the app away. So these are the default behaviors and are all based around user activation of your application. However, there are a lot of scenarios where your application needs to have some type of code running without a user actually actively opening your app. Now, some of those scenarios could be if you have a communication application, such as a chat or a VoIP application, if you're syncing with cloud services, if you're taking actions from rich toast notifications, or interacting with peripherals and sensors that are actually connected to the device. All of those scenarios require background activation. Now, in the Universal Windows platform, triggers are the tool to activate a piece of code in the background. So there are over 20 types of triggers in order to activate your application when needed. These trigger concepts should already be familiar with developers from Windows 8.1 and Windows Phone 8.1. but they may be new to some coming from either the agent model of the Silverlight Windows Phone 8.0 or from other platforms. So let's take a look at a trigger implementation. So in order to implement a trigger, your foreground application must first register the triggers before they can run. So registering in the trigger model is the equivalent of scheduling in the previous Silverlight agent model. Now, registration is done using the background task builder. You enter the name of your task, the entry point of your implemented iBackground task, and then define the type of trigger that your task should be fired on. So periodic task in the old agent model is the equivalent of time trigger in this trigger model. And resource-intensive task from the agent model is equivalent to maintenance trigger. So after you've done that, the final step is to call backgroundtaskbuilder.register. Now, you should remember to register or reschedule your background tasks every single time that your application enters into the foreground again. This is important as updates can occur in between runs of your background tasks or your application. And they could potentially remove your tasks from the task list. So many triggers are opportunistic. User configuration for background activity that's available in the settings or the battery saver feature could actually disable background activity for these opportunistic triggers. So you need to make sure, too, that you are monitoring your crashes in Developer Center for these background triggers and tasks, as too many crashes in a background task can also actually cause future instances to be throttled, very much in the same way that the agent model would throttle any type of crashing background task or consistently crashing background task. Now, the run method is in the implementation of your iBackground task. And it's the equivalent of the previous onInvoke method from the agent model. So in the run method, and in general your iBackground task, there are a set of APIs that are around audio capture, camera capture, location tracking. All of these are actually disabled by default for background activity, in the same way as the Silverlight model had them disabled by default. But your user can then choose to actively enable those for your background activity. Now, in this model, there's no longer a need to actually call notify complete at the end of your task. However, if you're doing async work, you do need to request a deferral. Now, requesting a deferral is done using this getDeferral method from the task instance parameter, and that'll keep your task from completing before any of your asynchronous work is actually done. Now, you need to remember to mark this deferral as complete when your async work is finished, or else your task will actually continue to run and then hit an execution time limit. The task instance also provides a cancellation event, as you can see this task instance.canceled, that then can be handled for any type of cancellation that happens due to execution time. So let's see how cancel fits into this lifetime of a background task. Now, in an ideal instance of a task, the run method is going to begin, and then work would complete well before the execution time. Any async work that happens, you would request your deferral at the beginning, and then you would complete your deferral well before that execution time limit has been met for your trigger. However, this isn't always the case, and we know this isn't always the case. When a task reaches the end of its execution time limit, it is terminated. Now, what if this task was actually working with connections that needed to be closed, or other actions such as database work that actually needed to be closed up in order for your application to be in a good state the next time it came back to the foreground? Well, the cancel callback allows for those actions to occur. Now, in your cancel, you're given an additional 5 seconds to do any of this closing up or cleaning up work. Registering an event handler to the cancel callback will allow that task, like I said, the additional 5 seconds of execution time. And it may not be enough to complete the original intended action for your trigger, but it will be enough time for you to close up any service calls, any database connections, anything else that you need to get your application into a good, safe state to come back up in the foreground. Now, by default, background tasks are given about 25 seconds to get to completed execution, and then with the additional 5 seconds of the cancellation time if that execution time limit is met. There's also a set of long-running background tasks. So application trigger and maintenance trigger, for example, can run up to 10 minutes. There are other ones that could actually run for an indefinite amount of time based off of a set of connections that they have. So device use trigger and RFCOMM connection trigger. If they're maintaining a connection to a peripheral or sensor device, then those could actually run indefinitely as long as that connection is maintained. Now, since Windows 8, by default, all background tasks run in a separate background host process that's distinct from your foreground process. Now, these two processes are within the same app container and can access the same storage locations. All of an application's tasks will run in the same background host process by default, but you also have the option of running these background tasks in separate background hosting processes using the resource group manifest edition. Now, this model of separate processes has its advantages primarily for resiliency in a number of scenarios. But there are also a number of scenarios where interaction between processes is required. And that's really complex and requires a lot of state management code in order to share anything between these two processes. So feedback from you as the developers was very clear on this subject. And in the upcoming release, we're really excited to introduce a new method for background activation, the single process model. Now, as a developer, you have a new choice. Instead of using the default separate background process, your trigger can actually be activated using an on-background activated callback directly in your core application. Now you have the option of working directly in core application. You don't have to create an iBackground task, and you don't need to actually communicate between processes if you don't need that type of resiliency of having a separate background task. So here's Stefan with an in-depth look at this new feature.
Hey folks, is this on? My name is Stefan Wick, and I will show you some code running in this new model, running on our latest bits. The bits I'm running on are not actually in the insider preview that we released this week, but it will be in an upcoming insider preview very soon. And so as I was planning the demo, I was looking through some of our SDK samples from previous releases, and a lot of them are like, hey, if you want to do X in the foreground, here, write this code. And then there's another sample, if you want to do X in the background, write this other code. And so if your app needs to do X both in the foreground and the background, you had to write the code twice, or you had to write a lot of brittle code to actually keep your background process and your foreground process in sync. So now with the new model, the single process model, we make this a lot easier. You write the code once, and it will run in the same process. And so in that sense, my coding demo will actually, for the most part, be a code deletion demo because now we have to write a lot less code. And so the demo I picked is about the contact store notification trigger. And so imagine you're writing a chat app and you want to leverage the contacts that are already on the user system in the contact store. You can use this trigger and the framework that we have around it to harvest those contacts for your application. And you most likely want to do this both when your app is in the foreground, actively being used by the user, as well as when it's in the background, not being used, not running or not being used by the user. So let's take a look at how that looks in Visual Studio and running on our latest bits here. So before I get to the cool part, I want to do a quick sidetrack here around best practices for around the battery settings that the user has set, and then the intent that the user has around background execution. So before you register for background activity, you have to request access. So this is not new. This has been there for a few releases. But we are now in the upcoming release, we're giving you more fine-grained information about the user's intent and the user's current configuration. So you can do a better job kind of doing what the user expects you to do, or also notifying the user about any configuration changes they can make to get the best performance and the best functionality out of your app. So the status that's returned by this method actually is not just a Boolean. It returns you an enum with a lot of information. And some of the key members I have written down here, and I want to show you how it maps to the new settings that we have in the battery usage part of our settings. So for an app, the user can select now, hey, this app is really important to me. I don't want the operating system to get into the way and be smart about background execution. I want this app to always be able to run in the background. So the user can make that choice here. The user can also select, hey, I really don't care about that app in the background. I don't want it to use my resources, so they can make that choice. And by default, an app, when it gets installed, it will be managed by Windows, which means we're trying to apply smart defaults in terms of battery saving settings. But at runtime, you can figure out, what is the current configuration, and you can react accordingly by notifying the user or by tracking the status. So now let's switch over to the registration part. So to register my contact store notification trigger, I write pretty much the same code as I did in the past. Actually, this code is taken from the past. And so one thing you notice here, in the past you'd specify an entry point for your background task, which in my case, lives in this other project, which is its whole separate WinRT component. It runs in a separate process, and I have to manage the state between my foreground process and my background process. So in the new model, I can just get rid of this line. I don't need it anymore. And I can actually get rid of this entire project here, so I'll just delete this as well. So when I told you, this demo is about deleting code, not about writing code, I wasn't kidding. And so now that I no longer have an entry point for my trigger, how does it work? So the way it works in the new model is that we have one event that fires in your application process. It's called onBackground activated. And so this fires for all your triggers that you might register. So one thing you want to do is check for the name of your trigger. So I called mine my contacts watcher, and so I'll check for it here. And now the code that I'm writing here is pretty much the exact same code that I had all along in my foreground app already to keep my app in sync with the contacts in the store. But now this code triggers both when I'm actively in the foreground as well as when I'm in the background or when I'm not running. So the same code runs in the same process, and I will be able to update my state right here, and it's right there where I need it and not in another process that runs in the background and I need to manage and sync up the state. All right, so let's see how this looks in action. Let me launch my People app here. So this is my vast social network. So I will run my little app here from Visual Studio, which is syncing with the contact store. And so let's put these side by side. So it has synced all my contacts, and now, if I go ahead and my contacts changes, either by making changes in the People app or through other means, my UWP up here on the right will always stay in sync here. So let's say, Anthony really goes by Tony, so let's make this change here. So now my app syncs that change. The trigger fires, and the changes are made directly here in the foreground app. So now what happens when I go in the background? So I minimize my app, which for UWP means it gets suspended, and so all threads are suspended. There's no code running, and let's say Daniel is no longer my friend, so I want to delete him from here. So Now my app is in the background, or it could even be in the non-running state. Still, the same code will fire, so we wake up your process for the background execution. Your code executes, and your state is up to date in the process where you need it. And so when the user comes back, the UI is already right there because the model has the right data. So, yeah, this is a single process model. It allows you to write a lot less code and get rid of a lot of the code that you might already have to sync up state, and just makes things a lot easier for many scenarios. With that, back to you, Chris.
Great, thanks. What was the number?
5.
All right, so Stefan showed you the 3 steps to enabling background execution before you can actually run code in on background activated. And the first was requesting background access using that background execution manager. And from there, you would get a background access status, and then you could also check battery saver to inform your user of any configuration needs. So as Stefan had showed you, in the new battery use settings, you can actually set as a user what you'd like your background activity to be for a certain application. And so you, as an application developer, should be aware of what the user has chosen and whether your application does need this background activity in order to enable, for example, a communication scenario, or whether it's something that's more of a passive syncing that isn't necessary to happen all the time. And then the final item is to register for that background activity. And that is, once again, using that background task builder.register. So let's go look again at that daily app usage pattern. Now, when your user moves away from your application, your app goes into the suspended state. But what if your app should be continuing to do some activity while they move away to complete another task? Let's say your user is listening to music or watching a movie with your app. Well, when the user is moving away to check their email or answer a text or Skype message, something, then they expect their media to continue playing in the background. Now, media playback is a core example of multitasking. And media playback in the background should be simple. It should be simple for you to implement. It should be simple for your users to expect that their media will continue playing in the background when they've needed to. Now, we've heard your feedback on the 2-process model that currently exists for background audio, and are really excited to bring you activity-sponsored execution. Now, all you have to do is simply add an entry to your manifest declaring your application to be capable of playing media in the background, and then press play. That's it. Any of the foreground activities that you would normally do, you can continue doing in the background now. So media player, audio graph, Windows audio session, media foundation, HTML, JavaScript, web audio, and audio video elements, those can all be used in the background in the same way that they would use them, or you would use them in the foreground with activity-sponsored execution. Now for this, there's no more need for registration. There's no more need to create a background task, and no more need to actually manage this 2-process kind of communication and the copious additional lines of state management code that were previously required. But what if you have to do something a little bit more complex in the background than just playing media? Well, extended execution is your generic tool for extending your running state when the user navigates away from your application. So let's say rather than the media playback app, you're writing an audio or a video or like a graphical workstation instead to create new content. So your app is going to require a compilation step in order to transcode, bring all those pieces together, and get a completed product. And this can take a lot of time. This time is often directly proportional to the actual length of the finished product or the size of the finished graphical product. So while this is running, your user doesn't expect to just stay in there and watch your application spin. They expect to be able to go to Edge, browse YouTube, go something else. So this can be accomplished using an extended execution session, specifically requesting an extended execution unspecified reason session while your app is in the foreground will allow you to extend your app and extend its running state even when that user navigates away. So it will not move into the suspended state. It can continue in the running state. Now, in Windows 10, the unspecified reason extended execution enabled your application to run for up to 10 minutes. And in the upcoming release, this form of extended execution will actually allow your application to run as long as needed when in the background, when you're connected to AC power, and would default back to 10 minutes when connected to battery power. So your user can decide to enable that longer runtime of greater than 10 minutes when on battery power by going to those battery use settings that Stefan had showed you and selecting the always allowed option for your application. Now, Stefan is here to show you how this extended execution fits into your single process model application.
Hey, thanks. Let me switch over here, back to Visual Studio. So I wrote this little app last night. Very important app. I don't know what it does, but it looks nice. What I want to show is kind of, in a way, the graphs that Chris already showed on the slides, kind of making those real, and how your code can change those graphs and give you more execution capability when you need it. So for that, let me launch a second app here real quick. So this is my little execution monitor that I wrote. It's basically it's just an app service that the other app can connect to, and so what the left app does is it sends periodically data about its memory usage to the right app, so I can graph it here as it goes through the various stages. So when I hit the bus, that's when it should start. So now it's sending the memory usage information over here. And so now when I go ahead and minimize my app, which by default will suspend your app, so all threads will be frozen. So no more data is being sent over to the other side. And now when I what happened? Let me start this again. So when I minimize it, which puts it in suspend mode, execution will stop. And so when I bring it back, it comes back up. And so to show that it's kind of real, so when I click on the balloon, I will actually allocate more memory, so it goes up. And so I can suspend it, it goes down again. So now my app in this state, it cannot execute any code. And there are many scenarios where your app in this state still needs to do work, right? Just like you've been able to do in the Win32 world or in your WPF or VB6 applications. You might still have some threads going there or doing important work. So you want to be able to do this work. And so let me show you how you can do this using the extended execution APIs. Basically, what I will enable here is I will request an extended execution session, and the code for this is fairly simple. I need to tell the system the reason, which in this case it's just the unspecified reason, and then I can request it. Similar to the background registration, you want to check here for the background access status. If you get denied, then it may be because the user has disabled background execution for your app. So you may want to respond to that and tell the user, hey, if you want the best performance of my app, then don't disable it in the background. So I've made this little change here. So let me deploy this back here to my system. And so, by the way, this applies to desktop and phone and all the other platforms where UWP is supported. So if on the phone your app goes in the background, or on the backstack, because another app goes into the foreground, then same concepts apply. So you can request this extended execution session and then keep doing your work while you are on the backstack and not in the foreground. So let me run this guy again. I need my monitor up again. So what was it? Hit the button, hit the bus to start the memory tracking. And so now if I minimize my guy here, you see the memory goes down. And so the system does some smart work here, knowing, hey, when you're not in the foreground, we can save you some memory. And also you get events, so you can release some of the memory that you don't need. But your app keeps running, and I keep reporting my memory data to the app service. And then when it comes back to the foreground, the system will resume it correctly, and all your resources are still there. Your animations will resume immediately, and everything's there right for the user. But also in the background, you can keep doing the work and accomplish the great features that you have in your app. Yeah, that's it. Back to you, Chris.
So Stefan showed unspecified extended execution, which is a running state extension. Now, extended execution can also be used for another type of background execution scenario, and that's extending the suspending state of your application. So applications are now dealing with user data and are rich, internet-connected clients. They're dealing with large amounts of this user-created data per session, and that needs to be constantly resynced to the cloud. Users don't expect a save button in their applications anymore. They expect their data to be saved at all times and be available across all of their devices. So one place that saving data occurs in the application lifecycle is in this transition from running to suspended, and that's within the suspending event handler. So an application is normally given up to 5 seconds to suspend. But what if this time just isn't feasible to upload all of that needed user data? Well, your application can request a saving data extended execution session, which will provide up to 10 minutes of additional time to asynchronously transfer any user data that you may have. Now, saving data is another extended execution reason. And the actual session is implemented in almost exactly the same way as the unspecified extended execution that Stefan just showed you. The only difference is that this session must be requested directly in your on-suspending event handler. It's important to remember that in the suspending event handler, you actually get a deferral for any asynchronous work in the same way that you would for implementing a background task. Now, when your async work completes, it's just as important to mark this deferral as complete so that your application will move into suspension quickly as it was for a background task. And extended execution offers a revoked callback, which also behaves similarly to a cancellation of a background task. So in this example, the backup behavior is to save that data locally to be uploaded at a later time in the case that your extended execution session is revoked. And so this extended execution session can be revoked due to a couple different system policies. It can be revoked due to hitting that execution time limit. It can be revoked due to hitting a memory limit for your application in order to make sure that other foreground applications can actually get up to the foreground, up to user visibility. So at that point, you should do any cleanup required to ensure a good user experience at that next launch. So saving data extended executions are also revoked when your application is moving from the background back into the foreground, so that now you are notified that your application is coming back into the foreground and you can resume normal work. So with that, we've covered the 3 methods for background activation and background execution. There's triggers, which fire based off of a set of system or environmental conditions, and that can run in a separate process or now within your core application directly. There's activity-sponsored execution, which is specifically for media playback and moving between the foreground and the background in order to play that media seamlessly with just a manifest entry. And then there's extended execution, which is the generic tool for extending either your running state or your suspending state into the background. Now, all of these are great tools, and they're all given a limited resource set to use. Now, in order to ensure a great experience across the user's entire device, you can be sure of your resource usage by dynamically investigating it. So memory usage, in particular, matters to the fast, fluid visual experience and the all-day usage of a device and all of the applications on it. So let's take a look at a new model for daily memory usage of an application now that we have these new tools. So with the new tools of activity-sponsored execution and extended execution, your app can move back and forth from the foreground into the background as your user moves to other activities. Now, memory management is particularly important as an app moves into the background. Why? Because as your application moves into the background, the memory limit for that application actually changes. Now, as Stefan said, the system will do work to reduce memory on your behalf as you move into the background. But you can also use a set of callbacks either when you're entering the background to remove additional assets from memory, or when you're leaving the background to load them up again before your application goes into the foreground and is back into user visibility. Now, in this example, you could see when the first move to background, the application is actually well under the memory usage limit. There's plenty of headroom for additional memory usage, and now we'll see that when the application is moving back into the foreground, it looks like there's something that the user has done to increase the memory usage of this application. So it seems like they've taken an action that could be one of those processing tasks that we had talked about before. Could be something else that's just a very memory-intensive action. And now, when this application moves back into the background, it's actually over the memory limit. So in past releases, applications would receive a memory allocation failure and be terminated immediately if this were to happen. But in the upcoming release, we're introducing a new policy where your application can actually be over that memory limit, and it can continue running. So memory usage can be followed using Memory Manager, and it has the tools for you to take action dynamically with this new policy. Now, in the past, an application would have to constantly monitor its memory usage and determine if there was available headroom before allocating any kind of large assets. And then we introduced an event-driven model that was introduced to let an application know when its memory usage was reaching those termination levels. So as a developer of a memory-intensive application, you were still kind of towing that line between being kind of at that high limit and just about being terminated. Now, as part of this event-driven model, you can actually allocate as needed and then take immediate action when your application is over the limit. So your application could run for 10 seconds over the limit. It can run for 10 minutes over the limit. It all depends on the usage of the total available memory on that device. So you can use these events to be dynamic and instead take action as quickly as possible when entering a danger zone rather than having to take precautions every single time you're allocating memory. So we've seen a lot of improvements in the upcoming release, and these are all based directly from your feedback. So with the new single process model, background activity can happen directly within your core application if you choose, or within separate background processes. There's no more need to communicate back and forth between two separate processes if you feel that that is not necessary for your application. Now, activity-sponsored execution allows media playback applications this ability to continue playing audio in the background with drastically reduced lines of code compared to what we already have up on the samples right now on GitHub. And then unspecified extended execution now can run as long as needed when connected to AC power. And then when on battery power, the user can then enable this long-running activity in the battery use settings like Stefan had showed. And then the final improvement is that over memory limit notification. Applications can continue running even when they're over their memory limit. Now you can be dynamic and take action only when you're entering a danger zone. So with these tools, Go out, build consistently great experiences. The next great experiences on Windows will be made by you. And let us know how these tools are doing, how they're meeting your needs. All of these improvements were made by the feedback from you and the actions that we took in order to make these building blocks better for you. So together we can create this great Windows ecosystem. Now for some next steps. So there are a bunch of great other sessions to check out, looking at the publishing apps and games to desktop, mobile, and Xbox, which is on at 10:30 if you're looking at how to get an application actually onto a device. Also, from an enterprise perspective, if you're looking to do the same with Windows Store for Business, that already happened earlier this week, so you can go check out Channel 9. Another good one that happened yesterday was app extensibility. So if you're interested in some of these other background execution scenarios, such as creating an app service or an extension platform, then you can go check this app extensibility on Channel 9. And then, of course, continuing your education at the Microsoft Virtual Academy online. So now we'll open this up for any questions that you may have. And if you have any questions, if you could please go up over to the mics to ask questions so that we can all hear it.
And we have some gift cards to hand out for the first 3 questions.
Hi. Yeah, thanks for that. That was useful and good improvements. So I have a couple of questions. So on Windows Mobile, you allow us to define some custom triggers, right? I mean, do you allow the same on Windows Desktop also? I mean, can you define custom triggers which apps can then register for?
Yeah, the trigger platform really now in Windows 10 is the same across all devices. So there is no difference there.
On Windows Mobile, earlier we had to define some XMLs and define custom triggers to that. Do you have APIs now to be able to do the same?
Is this an OEM specific question?
Yes.
Okay. Maybe we can talk about that offline afterwards.
Okay. Yeah. And my second question is, do you allow Windows Service to activate any of those triggers you define?
Can you say again?
Can a Windows Service actually activate any of the triggers?
Oh, like an NT service?
Mm-hmm.
No.
No?
No.
Okay, thanks.
We should go from the other side now. Yeah.
Is the single process background execution model available for use with VoIP background processes?
So currently VoIP is still supported with the 2-process model. Specifically right now what we've been targeting is media playback and then another set of generic extended execution scenarios.
Okay, thanks.
Mm-hmm.
Okay, so a couple of questions. The first one is regarding modern standby. Are all these execution models available during modern standby as well?
So it depends on the battery behavior of the different devices. Specifically for mobile devices, connected standby will actually cause a revocation of your extended execution session. But for media playback scenarios, for example, it will continue playing as the device goes into its concept of connected standby.
Okay, so extended execution will not be available during connected standby.
Right.
Okay. And the second question was whether this would also be available as an API for desktop applications. That's similar to the services question.
Mm-hmm.
When you say a desktop application, you mean like a classic
modern desktop app.
Like a WPF app or?
I mean an app that was like, for example, using the methods that's shown in the keynote for bringing in
Centennial app.
Project Centennial app.
Yeah, so for an app that you run through the converter,
yes,
it will run the exact same way as it did before. So you already had those capabilities to be able to run when minimized. So
not during modern standby.
Oh,
so
okay.
not
yes.
for the, yeah.
Okay.
So.
Yes. With the desktop app converter, you will then be able to add background tasks to your package that will run in the modern context. So you will be able to take advantage.
But then it would have to run in a separate process.
Those will run in a separate process. Yeah.
Okay. Thank you.
Ooh, it should also be clarified that for extended execution, there is also another reason that's called location tracking. So if you're specifically targeting location tracking scenarios, that actually will continue running in connected standby.
Okay. For desktop apps as well? Okay, thanks.
Comment, then a question. It'd really be helpful to have one sample, a robust, I hate to say teach text, me old, working on original applications back in 132 or Apple days, that would be really robust, show you how to use this stuff, show you how to use extended execution, and not just async everywhere that might get you in trouble when you go to quit, right? And nothing really, there's really nothing to look at to say, this is how I do it right, and catch exceptions either. And you end up, quite honestly, in a bug-riddled program that you don't know why it's bug-riddled, right? Because things could throw exceptions, and you don't catch it in your handler. Anyway, it'd be really nice to have one very robust example that shows both how to handle async right, long-run async tasks you might do in the middle of your app, like exporting something to some slow server, and when you get asked to quit, how do I stop that, right?
Yeah.
Anyway.
Yeah, this is good feedback.
Yeah, it
and so we will have a new set of samples
Yeah.
with the anniversary release this summer, which will cover all the new functionality here as well.
Yeah.
And yeah, so this is good feedback. I think what you're saying, make it a little bit more real life, real world, and
Well,
less
more just
academic.
all the samples, people are cut and pasting code that's buggy because they don't realize you need to put try catches everywhere.
Yeah.
Or an async
Yeah.
task that runs a long time, you're in trouble if you go to quit. You let that thing
Right.
run. So anyway, and the other thing is, thank you for this, because honestly, every other mobile platform for something that's big images or something, it's a disaster. It's, you really got a gun at your head, and most of the reviews are, you lost my files, you lost my work, you lost, You can pull all this off of this. Now, on the last question, so if you have extended execution, can you have two of those going at once? You said, so if you've got to stop the one, that's, you start with an unknown before you get on quitting or whatever. Right?
Right, so you can only have one extended execution
Yeah.
session at a time.
So if you had a bunch of async tasks you had running, which you could cancel, when you got on quitting, you should go have pointers back to them and say, stop what you're doing.
Right.
And then you should say, if there is something you got to finish writing, you say, hey, I'm saving a file. That's the proper pattern?
Yes,
Okay.
yes, exactly.
Cool. Thank you.
Please.
Hi. Are all these APIs available for WinJS?
Yes.
Thanks.
So this is not particularly related to the new release, but are these events available to a library rather than the app directly? As a library, as an author of a library rather than an app, how can one take advantage of all these triggers and events?
Yeah, there's nothing stopping you from using it in a library. There's one thing to be aware of, though, with the extended execution, since an app can only have one session at a time, so the library should make it clear to the consumer of the library when this is happening, in case they are taking their own session or they have another library that's also taking a session.
Right, makes, thank you.
It appears the suspension is immediately invoked by minimizing a window. On Xbox, what's the equivalent? Because I'll be in an immersive app and maybe go to the dashboard and it's still running in the bat. Is
Right.
that a suspension state?
Yes, yeah, that's exactly it.
So my
So,
video will stop playing if it's in the bat on the dashboard.
so it will currently, in the upcoming release, though, activity-sponsored execution for media playback will specifically enable that for any type of background media playback for Xbox.
So if they go to the dashboard to change parental controls and then come back to my app, my suspension eventing is the way to realize I'm back in the foreground.
Yeah, so you will still get a resuming if you're coming back to the foreground from that.
Cool, thanks.
So for a Centennial app, my understanding is there's a desktop process and a UWP process. When it's suspended, are both processes suspended?
So we're not suspending the desktop process in the Centennial world, only the UWP process.
Okay. And we can still communicate between, we could have background processes in the UWP and communicate.
Yeah, when the UWP is suspended and you are hosting an app service there, that can be woken up, but then it's back in the running state, right?
Perfect. Thank you.
Any other questions?
All right. Well, thank you, everybody, for coming.